Welcome. In this tutorial we are going to learn about a new rule which I have derived from myself. I call it 1, 2 and 12 rule. I call it so because it can be used like a mnemonic code because it's very easy to remember the constants 1, 2 and 1, 2. So let's get it started. This rule is applied to find the sum of n consecutive natural numbers from 1 to n. You must have known some of the important formulas like summation n cube, summation n squared and summation n. But we are not going to derive it in the common approaches that we use in our school, but we use a completely different approach of calculus to derive this formula and see the beauty between calculus and the summation. So let's begin. Let's see for summation n cube. Let's apply this rule. According to this rule, you take this n cube like this, then divided it by 1, 2 and 12 as shown. 1, 2 and 12. Then the important part comes, which is integrate the first term from 0 to n with respect to n. Don't do anything to the second term and use differentiation for this third term. Just look at how the function, its integration and derivatives are related to this function. So with simplifying this, integration of n cube will give n4 by 4. This is the same function, and the differentiation of n cube over 12 with respect to n will give 3n squared by 12. And after simplifying, we will get this result, and it will finally simplify to the equation that we have already seen. So this is for summation n cube. So what about summation n squared? The same thing happens. Just bring n squared in 3 terms, divide it by 1, 2 and 12. Integrate the first term from 0 to n, keep the second term as it is, and differentiate the third term with respect to n. After simplifying, we will get this result, and by simplifying we will get the result for summation n squared, and the same is with summation n. Keep n as shown in the figure, divided by 1, 2 and 12. Integrate the first term and differentiate the third term, keep the second term as it is. After solving this, we will get this expression. But one interesting thing about this expression is that it contains a constant term. Actually, this will not be included in the formula. The interesting part is that the zeta function of -1, or the analytical continuation of the summation of the consecutive natural numbers, which is equal to -1/12, that is also featured in different videos in YouTube, and it's one of the popular series, and this -1/12 is related to this number 1/12. So it's very interesting. We will discuss in these matters in the later videos, but for today just remember that the constants should not be included in this formula, and we will get the result as n plus 1/2, which is the required relation. But the question arises, does this rule work for the following expressions? For summation n to the 4 or 5 or 6? The answer is no, because we have used the constants 1, 2 and 12 such that it works only up to summation n cube, and for higher powers of n it doesn't work. There will be other constants than 1, 2 and 12. So for higher powers, I have already made a video on expression, so you can refer the link in the description. So thanks for watching.